All right, let's take a look at factoring expressions. In our page sorter here, let's head up to the top. This is the same exact learning goal as last time. We're just getting a little bit more complicated, I guess. So learning goal number 23, you can go ahead and fill that out. And put your date. All right, scrolling down to this lesson. Let me get rid of the page sorter here. All right, factoring expression. So in key concepts, remember that a simplified expression has no parentheses. Parenthesis. And we get rid of the parentheses through distributing. Okay, by using the distributed property. And it also has no like terms. Okay, and this is through combining. Okay, all right. A factored expression is going to be an expression written as a product. So we mean 5 times, and then we have the parentheses. So this is a factored expression. Okay, so here's just an example. Okay, all right. So now what we're doing here is we have 3 kids, Chris, Katie, and Emily. They've all factored this 54b plus 12. But they're having a disagreement about who did the best factoring or who factored it correctly. So what we want you to do is go ahead and finish their factoring based on what they factored out. And then you can look and see who did it best. Okay, so if we look at Chris's, Chris factored out a 2. And so if he factored out a 2 from that original expression, we have half of 54 is 27b plus 6. Okay, and then when we look at Katie, Katie factored out a 3, so 54 divided by 3 is 18b plus, and then 12 divided by 3 is 4. And then Emily factored out a 6, and so 6 times 9 is 54, so 9b plus 2. Okay. Now, when we look at these, what I want you to notice is that Emily ended up with a 9 and a 2 when she factored out that 6. And if you ask yourself, can anything else be factored out of 9 and 2? The answer is no. So what I want you to do is I want you to write that Emily did what's called factored completely. Okay, so Chris and Katie did factor their expression, but they didn't factor completely. And what I mean by that is, if you look at Katie's here, the 18 and the 4 could be factored more. So you could factor out a 2, okay, out of those. Okay, so I have like 2 times 3 out here. You could factor out a 2, and you end up with the 9b plus the 2, which is the same thing on the other side. And when you multiply the 2 times the 3, you can see we end up with that completely factored expression. Okay, so I just wanted you to get to see how that works and what that means. Okay, so as far as who best factored the expression, we would say Emily, because, here's an abbreviation, she used the greatest common factor, or GCF, okay, and she factored completely. Okay, so that's why hers was the best option, even though the other ones are accurate. Okay, all right, let's go ahead and look at these next ones, and we're going to go ahead and factor, but it says completely, so you do have to make the best decision. Okay, for this first one, though, I'm going to show you what would happen if you didn't know what the best GCF is, because that's something that honestly might happen. You just may not know. So I always look when I'm factoring, trying to find the greatest common factor, I'm always going to look at the 16 because that's really going to drive this, and think about your factors of 16. So I know 1 and 16. So I don't know, let's say I don't know if 16 can be factored. 16 times something is 72. Let's just say I'm not sure. Okay. And so I pick something that I am pretty sure. So let's say I pick something completely wrong, and I pull out a 2. Okay. So if I pull out a 2 or factor out a 2, our 72 divided by 2, let's see, 35 is 36. Okay, so 36x plus 8. Okay, so I definitely did not get the greatest common factor. Okay, so I picked 2, and I know that because 36 and 8, I still can factor those, okay, and find a greatest common factor. So they're still even numbers, so I know I can even just pull another even number. I know that, let me think, I know that 4 times, let's see, 4 times 8 is 32. That doesn't work. I know 3 times, let's just say we pull out another 2. So if I pull out another 2, I end up with 18x plus 8 divided by 2 is 4. Okay. So now the 2 times 2, I've technically pulled out a 4 at this point. Looking at these again, I still know I can factor them further. So the reason I'm showing you this is showing you that if you do make the mistake, you're just going to have extra work, which is going to be a time waster, but you can still get the right answer. So I can factor out a 2 of both of those again. So I'm going to put a times 2 over here. Okay. And I end up with 2 times 9, x equals 18, plus 2 times 2 is 4. Now I cannot factor out any more from the 9 and the 2. So I have what's called, remember, factored completely. Okay, so that's the process. If you're not sure what the GCF is, that is something that you might end up doing, or a couple other options that I'll show you in a minute. All right, so let's go ahead and look at number 3 here. Okay, so I'm looking at the 12 minus the 66. For this one, I'm thinking about my 12, and let's see, factors of 12. For this one, we can pull out a 6 for both of these. And so we have 6, and then 6 times 2 is 12. Okay, and then our 6 times 11y is going to equal the 66, or in this case, negative 66. Okay, so that is correct. If I wanted to, I could pull out a negative 6. I would just have to have a negative 2 plus 11y here. Both of those are accurate. Now, I do want to talk about another option rather than what you see here in the other problem. Let's look at another option here if you don't know the GCF. So one of the things you can do is write 12 and 66 and sort of show your little division here. And let's just say I only know that 2 can be factored out of those. So 2 times 6 is 12, and 2 times 33 is 66. Okay. Now I look at those, and I can do that sort of division again. Okay. And so I know that for this, I can pull out or factor out a 3. So 3 times 2 is 6, and 3 times 11 is 33. So when I multiply those, I know that I could have then pulled out a 6 overall, okay, to get that 2 and 11. Okay, so that's another option for you if you have trouble identifying the GCF right away. All right, number 4, for this one of 36 and 84, we can factor out a 12. Okay, because they're both negative, I'm actually going to factor out a negative 12. And then that means that this is going to be a 3m inside. And then plus 12 times 7 is 84. So because I pulled out of the negative, I just do want to double check those because they're trickier. 12 times 3 is the negative 36, and negative 12 times 7 will get me that negative 84, okay, that we have. So that is accurate. All right, let's go ahead down and look at these bottom 3. It just says write an equivalent expression for each algebraic equation. And I would say to you, for these ones, let's use either distributive or factoring. That way you can't just say, oh, well, according to commutative property, I can just flip-flop those, and there's your equivalent expression. I actually want you to practice factoring or distributing, so let's revise the directions a little bit. All right, let's go ahead and show distributive here. So we have negative 4 times 2 is negative 8x, and then the negative 4, I'm going to KFC that, times the negative 5 is actually a positive 20. Okay. All right, next one, we're distributing this way. Okay, and so we have the 6 times the 3x is 18x, and then the 6 times the 4 is 24, okay, depending on how you want to say that. All right, and then the last one, it's in this form, so I'm going to factor it. So I'm looking at the 5 and the 45. I know that I can factor out a 5. So I'll go ahead and factor out the 5. And so 5 times negative x will get me the negative 5x. And then 5 times the 9 will get me the 45. Okay, or I could have pulled out the negative 5 and done negative 5 times x to get to the negative 5x. And then I would have to have the negative 9 here so that I have the negative times the negative gets me the positive 45. So both of those are accurate options. All right, that is factoring expressions.